Hello, Roshan. Happy April Fool's Day. I don't know if very many people are going to attend because I know some people attended the 2:30 to 4 session. This is going to basically be the same thing. So give me 1 second. I'll be right back. You guys can chat amongst yourselves. How are you guys doing? You guys can turn your mics on if you want, turn your video on if you want. I like to see you guys. My girlfriend is an elementary school teacher. She teaches the 5th grade, and she's teaching classes right now online. And she's got pretty good participation. Not everybody's able to participate, but a lot of the students are participating, and they turn their video on and they talk to each other. I guess the 5th graders like to talk to each other, talk a lot. So let me wait a couple more minutes to see if anybody else joins us. I'm going to give you something interesting to look at. Yes, I'm almost done. I apologize for that. And I apologize for Monday too, by the way. Because of the nature of the other stuff that I do, Monday was a terrible day for me. Well, not a terrible day, but it was a very difficult day because I have several clients. I don't have a lot of clients, but the clients that I have are pretty high level clients, and they're very demanding. And I had to jump through a lot of hoops to get a lot more remote networking set up than they realized they were going to have. This didn't really set in for several of my clients, the fact that we are pretty much stuck at home and not supposed to leave. Even for the clients and the companies that run critical applications like supply chain clients, they're required to still try to maintain social distance. So only half the employees are going to work, for example, every other day. So I've been having to scramble to help these clients set that up. So like I said, I apologize for Monday. What I'm going to do, guys, by the way, for chapter 8 is, because I don't think we've talked about chapter 8 at all, is do an asynchronous offline. I'm going to go ahead and do a Zoom meeting, but I'm going to record it, and then I will publish that on YouTube. I just learned how to use YouTube. I made, by the way, the subnetting recording, the subnetting lecture that I did last time we had class. I published that. Did you guys, anybody get a chance to look at that yet? Did it look okay to you, Hyder? It might have been a little grainy, but I think it, hopefully it's very helpful to you guys. It may not be 100% correct, kind of on purpose. I mean, the first 3 or 4 that I did were, don't get me wrong, but as we got to the end, I was saying, okay, suppose we didn't have these other companies, where would this smaller company fit in? Where would TinyCo fit in? So where we were fitting them in into the chart wasn't exactly where they go, but hopefully that video will help you. So right now I want you guys to concentrate on getting that subnetting assignment done. Can the due dates be changed on Blackboard? Of course they can be changed. In fact, all of my assignments, by the way, that are on Blackboard right now that have certain due dates on them, you can still turn that stuff in even after the due date. It just says that it's late. But I'm not going to count off on any of this because of what's going on. And I'm far behind on stuff. But yes, to answer your question, Danny, and everybody else, I'm almost done. I've got all of the exam 1 grades. I've got all of the grades in for the first 2 classes that I teach. The first class I teach, the 477 from 2:30 to 4. Applied a little bit of a curve. I'm still looking at a few more exams. I've graded some of the exams in here. There's no curve applied yet. It's not going to be a big curve because most of you did pretty well. So let me get that finished. As soon as this class is done, the good news about today, what is today? Is today Monday? Or is it Wednesday? Gosh, it's all running together. Thanks. Is anybody else having that problem? You can't tell what day it is? Or is it just me? Please tell me it's not just me. Okay, so what day is it? I don't know. I'm in the same clothes I was wearing for the last 3 days. No, that's not. Haha. I'm sure a lot of you are. That's what my girlfriend was saying. Oh, I haven't changed clothes in 3 days. It's like, well, I'm not coming over then. So I have more time now. We've got our clients dealt with. They're all happily sitting at home, or maybe not happily, but they're sitting at home on their laptops with their VPN, and they're using Skype, or they're using a VoIP. They're using Zoiper, or some sort of VoIP application on their computer to act like a phone. So they're able to get their for the lucky ones, they're able to still work. Most of my clients are, they're not manufacturers. Most of them are consulting type clients or attorneys, things like that. Even my doctor's office clients, it's kind of interesting. They're doing telemedicine. They're setting up appointments and they're seeing patients with Skype or with FaceTime. Has anybody done that yet, by the way? Or anybody know anybody that's done that? Talk to their doctor over FaceTime or Skype? St. Luke's is, yeah, a lot of, like I said, several of my physician clients, they're doing that. So you can go see the doctor, but you're seeing him on Skype. So anyway, I'll get them done this evening. I promise. I know I promised last time, but that was before the world blew up. He has a virtual doctor's appointment. And since we're all going to be having to live like this for at least the next month, I don't know if you know this. Well, I think most of you do know this. The governor of Texas extended the stay-at-home request. I don't know if it's an order to May 4th, which means we're basically not going back to school the rest of this semester. We probably are not. We possibly, I shouldn't say probably, but we're possibly not going back to school for the summer. Were any of you in here planning on taking a summer class? No, yes. What does GG mean, by the way? Good going? I don't know what GG means. Is that like LOL? Good game? Okay, good game. Oh, I should have known that. I used to play all those games. We used to say like woot grats or grats. Like if you leveled up and what was that game everybody used to play before Fortnite? Wizard? No, not Wizardry.
Minecraft.
No, before Minecraft.
Minecraft. Wait, what was before Fortnite?
you guys are too young. Oh, the online stuff. World of Warcraft. We called it World of Warcraft. It was World of Warcraft. Thank you, Joe. We called it World of Warcraft because if you were like me, you'd literally play it for 19 hours straight and not realize what day it is or whatever. Anyway, so should have all the tests graded, should have everything graded. If you're missing something, by the way, make sure you go in there and get it done, because although you might have participated in making the network cable or you looked up your IP address, you did not submit an online assignment. I have to see something so that I can grade something that shows me, yes, I completed this. I did this thing that you wanted me to do. Get the subnetting assignment done as soon as you can. Let's get into chapter 9 here, okay? You guys ready for chapter 9, the WAN network chapter? So and that's okay that we're doing this a little bit out of order, even though we didn't really talk about backbone networks, because they're related, and we could teach these in any order, but that's okay. Let me share my screen. Let me know if you guys can see this. Gesundheit. Let me move some things around on my screen here so I can see y'all's lovely faces. Again, if you want to turn your video on, please do. I like to see people. Otherwise, I'm just talking to icons or names. And ask questions if you want to. Unmute your mics and ask questions if you need to. Like if I start going down or if you can't see the screen for whatever reason, I may not see the chat window. So make sure you say something like, hey, Jake, something's wrong. Let me know. Let me stretch this out. When is your next exam? Probably, did I mention that already? Probably Wednesday. Maybe even tomorrow evening. I'll probably make it available and open it from Wednesday to Saturday at midnight to take. It's going to be just like the first test, online. Make sure, and it's going to probably be, I'm going to guess, easier than exam 1. Yeah, by tomorrow. I'll try to get it up by tomorrow. Let's see. Wait a minute. No, not next Wednesday, this Wednesday. So, oh, I forgot. See, I keep thinking this is Monday. Let's get through chapter 9. Make sure you get the subnetting assignment done. And I may go ahead and post it this evening. I may get exam 2 up there this evening. I'll send out a link, an announcement, and let you know. But we probably need to take it as soon as possible to get her out of the way. So you'll have a 4-day window to take it in. I probably won't run it in next week. Let me think about that, because like I said, I was operating under the premise that it was Monday when it's really Wednesday. So I may make it do like Sunday at midnight, something like that. I'll let you know. Okay, so chapter 9 is about wide area networks. WANs, wide area network. Now, you guys probably think about WANs in terms of the internet. Your WAN connection is the internet. That's not the traditional WAN connection. A traditional WAN connection is a point-to-point connection where an entity or an organization that has 2 or more locations wants to connect those 2 locations together that are geographically separated. Either physically geographically separated by a body of water, or they're long distances from each other, several miles or several hundred or several thousand miles away. So WANs are typically point to point. That's what makes it different than an internet connection, which is point to the rest of the world, or single point connection. It's not really single point. That's not the right term, but we're talking about point to point or multi-point connections. We've got different service types. We can either set up WANs in a dedicated circuit network fashion, or what's called a packet switch network fashion, or what's called virtual private network. Now, I know a lot of you probably heard of that term VPN before, and you're probably using, if you've ever used a VPN, for very specific purposes, which we'll talk about in a minute. So first of all, a wide area network runs, and that's really not really correct to say long distance, as a WAN can be 1 mile. It doesn't really refer to a geographic scope. It refers to the part of a company's network that they don't own because they have multiple locations, typically in different cities. It sets itself apart from a backbone network because a backbone network, which again, we haven't done that chapter yet. I still have to publish that on YouTube. Most companies own their own LANs. Most companies own their own backbone networks, like we do at U of H, but we don't own our WAN connections. We connect to the other campuses, Clear Lake, Victoria, the other campuses that we have, but we don't own those cables. We lease them. We rent them from what's called a common carrier. Make sure you understand and know what that term is, common carrier. If I ask you that question on the test, a common carrier is any organization whose primary job is to provide internetworking services to businesses or individuals, not necessarily internet. Why did that pop up? That's weird. But oh, I know why, because I was recording a video. Uploading a video. Internetworking services, AT&T is probably the most commonly used one in the country and the biggest one. But there's some others that maybe you've heard of, some you haven't. Sprint, Verizon, BT, which is British Telecom, Telefonica, which is in Telefonica is that South America or Europe? I can't remember. Level 3, that's here in the United States. You've probably never heard of Level 3. Level 3 is the company that provides Comcast with their backbone network, because Comcast doesn't necessarily have their own. Tata, anybody ever heard of Tata Communications? Anybody from India in here or Southeast Asia? They use Tata Communicate. They're big in India. That's like their version of AT&T. Common services, and this is why they're called common carriers, because they provide these common, or also called public, services that anybody can subscribe to, just like you can subscribe to the publicly switched telephone network and get a telephone number. Dedicated circuit, packet switched, or VPNs, virtual private circuits. Dedicated circuit networks, these operate at layer 2, the original ones that were set up, operate at layer 2, not layer 3, layer 2. Using full duplex circuits from common carriers, we call those leased lines or private lines, to create a point-to-point link between organizations' locations. Typically, they're not Ethernet, or the original ones were not using Ethernet. This is layer 2, so the most common layer 2 protocol is Ethernet, but we use PPP. PPP stands for point-to-point protocol. We dropped the T out because it just sounds better to say PPP, point-to-point protocol. The way this works is, let's say I have a business in Houston and a business in Dallas, or it's the same business but 2 different locations, and I want to connect them together with a very secure network because I need to share secure data. Or my servers in Houston, I've got employees in Dallas, salespeople in Dallas, for example. I want them to be able to see my shared hard drives, for example, on my Windows server. So I will call up a carrier that hopefully has service in both cities, like AT&T, and I'll say, hey, I need a dedicated circuit What's that going to cost me, and what do you have? And AT&T will say, yes, we have dedicated circuit services. We have T services. We have SONET services. We have Metro Ethernet services. We have MPLS services. We have packet switch services. What would you like? So you order that from them. Takes a little while to set that up, sometimes weeks or even months to set it up, especially if the cabling, you don't have the cabling coming to your building. And also they have to do some internal wiring. They're basically, it's kind of like this, AT&T, pretend that they're a provider of freeways. And you need to drive from Houston to Dallas, and you want to make sure that you can drive as fast as you want, that your employees and you can drive as fast as you want, have exclusive use of a freeway so you don't get stuck in traffic. So think of the internet as our modern freeway system where sometimes there's traffic, sometimes there's not. A leased line or a dedicated line is a modern freeway system, but you get your own lane, or better yet, you get your own toll road, you get your own freeway. They will build a freeway, a logical freeway from Houston to Dallas for you, only for your organization and their vehicles to use. Nobody else can use it. That's a dedicated leased line. They use devices that look like the modems or the routers that you have in home. We usually just call them modems these days. The original term was called a CSU, DSU, but we don't call them that anymore. They're billed at flat rates. There's no per minute usage. Unlimited use of the circuit. You can do whatever you want with these layer 2 circuits. You can run any kind of whatever layer 3 traffic you want on top of them. That's not the requirement. That's not the responsibility of the organization. You can run internal 10.0.0 networks on top of it. It doesn't matter what you run on it. They're just giving you a layer 2 network. It's expensive though. Takes a long time to set up. There's usually a large install cost, anywhere from $1,000 to $50,000, depending on what they have to set up. And they usually require you to sign a long-term contract, 3 to 5 years or more. They're hard to get out of. I was trying to recently get a friend of mine out of one of these contracts where he was paying $1,200 a month for a 10 megabit per second connection, which sounds pretty slow, doesn't it? But it was dedicated, but Comcast wouldn't allow them out of it. So they're being sued right now. Anyway, this is what the topology of a WAN network or dedicated circuit WAN network might look like.
Alexa,
these might be different locations within a city, or these might be different cities. The thing that's common to all of these is that common carrier is one company that has a point of presence. That's important. This carrier, whoever it is, AT&T, BT, Level 3, whoever they are, they have to have what's called a point of presence, or a POP. Within each of those locations you want to connect together. If they don't, then you can't get that dedicated carrier service at layer 2 to that location. You have to go with some hybrid setup.
Alexa, 28 plus 64.
Now, topology. Let's talk about topology for a minute, because topology, unlike a LAN, the most common topology in a LAN network is a star topology. Actually, same thing in a WAN network. I mean, in a backbone network too. It just looks like a hierarchy, but it's a star topology. In other words, take the United States picture out and take the North America out of that for a minute. That's what a LAN topology looks like. You have a central connecting point somewhere in a closet, and then each one of these are PCs or printers or cameras or whatever they are, or these are wireless connections. But it's a star topology, and that works fine for a LAN. This is the most common star topology for WANs. I'll just go ahead and sit on this for a minute. So in this example, there's a company that presumably their headquarters are in Toronto, Canada, and they've got remote offices in Vancouver, San Francisco, LA, Dallas, Atlanta, and New York. They need to connect these remote sites together.
Alexa,
So they call up a common carrier
27
such
times
as
1.25.
and they say, hey, AT&T, do you have services, dedicated services in each of these cities? Why, yes, we do. Okay, we'd like to set up permanent virtual circuits between all of these cities and run them all back to our Toronto office. So they'll set that up for them. Takes a few weeks sometimes to set that up. Each one of these, pretend each one of those is about $1,000 a month. So each one of those blue lines is $1,000 a month. These are,
Alexa,
let's just say that they're 10
2 to the
megabit
power 3.
lines, okay?
2
These
to
are
the power
dedicated. It's just
3.
like building, as far as you're concerned, as far as the company's concerned, that's a
Alexa,
dedicated highway for
2 to
you
the power 4.
from Dallas to Toronto.
2 to the power
Now,
4
from
is
their
16.
standpoint, the way they're looking at it is it's not really
To the power
it's not a
6,
dedicated
Alexa.
highway.
2 to the power 6.
There's actually maybe 30 or 40 different
2
pieces
to
of
the power
hardware and
6
different
is
wiring, and
64.
maybe some of it's wireless. We don't know, and we don't care. The carrier cares, but we don't care what our connection is physically, as long as we're getting that guaranteed speed that we paid for, whether it's 1 megabit or 10 megabit or 100 megabit, whatever we paid for, and that nobody else can see our traffic at layer 2. It's better, by the way, for security to carry stuff at lower layers. What did I say about the internet model before? The lower down you can do your security, the better. If your security is at the physical layer, meaning there's locks on doors or there's no physical way to get into your network, that's the best security. The next best security is layer 2, because the only way you can jack into a layer 2 network is you either have to plug into a switch in the network, or you have to grab some Wi-Fi signal and get on that Wi-Fi. That's the only way that you can get on layer 2. With layer 3, all you need is an IP address. So layer 3 is less secure. So the original dedicated networks were layer 2. Also, layer 3 didn't exist yet when these things were developed. So this is the most common kind of setup, a star topology. It's the advantages to a star topology are that you're never more than 2 hops away from one site to another. So if Dallas needed to send a message to LA, that frame, not a packet, but a frame, is going to go from Dallas to Toronto, and then from Toronto to Los Angeles. Actually, it's a different frame, but it's the same message. So you're 2 hops away, relatively short speed, short hops. So fast speed, I should say. 1, 2, 3, 4, 5, 6 connections in this example. Now, most carriers, when you call them, they will suggest, especially, and this is a large WAN. This WAN encompasses North America. Your WAN could encompass the entire globe, or your WAN might just encompass a city. Nevertheless, there's still WANs, because you don't own the land. You don't own the connecting points between your different locations. So you can have a WAN within a city if you have a location in the Woodlands and a location in Sugarland and a location in Baytown, and you need to connect all 3 of those together in a secure network. You would want to set up a WAN, although that's only a 50-mile radius. That's not very big. Most carriers will recommend that you do this. You set up a ring topology for your network. Ring topologies are how we used to originally set up LAN networks, but we don't typically set up LAN networks that way anymore because we don't really need to most of the time. The difference between a ring and a star topology physically is very obvious. The same cities are still involved here, but rather than having a freeway dedicated from the central site to each city, we make a big ring. The advantages to this are that there's no single point of failure. In this topology, if something were to happen to Toronto, power went out, there's a strike, or there's just too much traffic going in and out of Toronto from all the other sites, that can become your bottleneck. There is no bottleneck there. Also, and the reason that most carriers recommend this is in this kind of topology for a LAN, where your LAN cabling is literally maybe a couple hundred feet or less, it's not very likely that that cabling is going to be damaged or that anything's going to happen to that circuit. What do you think is the likelihood of this circuit from Vancouver, 3,000 miles away, to Toronto? What do you think the likelihood of something happening to that circuit is as opposed to a LAN circuit? It's much, much greater. Lots of things that could happen. First of all, this is a much more physically complex circuit. There's 10, 20, 30 different devices possibly within this circuit. It's not the same cable. It looks logically like one cable, but it's not one cable. It's 10 or 20 different cables. There could be, Farmer Sven in Minnesota here could cut a cable in the ground and with his tractor, and that'll take this WAN connection down. And that's much more likely to happen. And it also takes a lot longer to fix those things because it's hard to find them sometimes. Also, if Farmer Sven does cut the cable there, it affects one customer versus affecting 10,000 customers. So the likelihood of AT&T giving you high priority is not going to be very high compared to a cable cut that takes out 10,000 or 30,000 customers in the medical center. They're going to look at that first and deal with that first. So most providers, most carriers, most common carriers say, you should get a ring topology network. So every city has basically two freeways or two ways out rather than just one door in and out. You got two doors in and out. The advantages to this, spreads out the traffic a little bit. It's less susceptible to an outage at the central site. If Toronto goes away either temporarily or otherwise, these other cities can still talk to each other. And if Dallas, or let's say if this link from Dallas to Austin or Atlanta here goes down because Farmer Joe cut a cable in Mississippi, or somebody goes on strike in Louisiana, or something happens to this connection, they can still get data to Atlanta. It just has to go the long way around. So ring topology is more recommended for WANs, not more common. This is more common because, for a couple of reasons. One, because most companies grow this way. Most companies don't immediately open and go, we've got 50 locations remotely. They open and they have one site, then they add cities on one at a time. And so WANs typically grow in this fashion as a company grows. So a star topology grows as a company grows. Ring topologies help you mitigate the loss of a circuit temporarily. And sometimes a circuit just goes down for 5 or 10 minutes. Maybe it's not Farmer Ted cutting a cable. Maybe it's just a technical problem. A technician made a typo and typed in 192 instead of 191 on a broadcast address like I did in the subnetting class. I made a little mistake and then doesn't realize it for 10 minutes. Well, he could have killed traffic for 10 minutes. How many cables here? We got 1, 2, 3, 4, 5, 6. Each one of these is, let's pretend it's $1,000 a month. That's $6,000. In a ring topology, that's 1, 2, 3, 4, 5, 6, 7 connections. So that's $7,000 a month. Cost more money. Also, instead of having one modem in every city, I have to have 2 modems. Or I have to have a more expensive device that has 2 WAN ports on it instead of 1. Also, the management of this network kind of goes out the window because it's now decentralized. There's no single point of control. There's no single point of failure, which is good, but there's no single point of control. I can't, if I needed to take my network down, I can't go, oh, let me shut down the Toronto router and that'll shut down the whole network. It won't. It'll shut down just Toronto. Some companies will opt to go with a mesh network, a mesh architecture. And it should be pretty obvious why we call this a mesh architecture. Here's an example of a full mesh network. So it's the same cities here, but we've connected in this example every city to every other city in this organization. So that's 1, 2, 3, 4, 5, 6. There's 6 connections from every city. There's 7 cities, so that's 42 WAN connections. $42,000. If each one of those blue lines represents $1,000, that's very expensive. Most companies cannot afford and do not need the hyper reliability of a full mesh network, but maybe they need some over reliability. So a lot of companies choose to go with a partial mesh network where they connect their more important cities together, where they're trying to mitigate certain things like maybe San Francisco and Atlanta need to send a lot of traffic to each other all the time, and their ring network was bogging down, or their star network was bogging down the Toronto office or the Dallas office, because all their traffic was having to go through these offices. So they said, let's just get a connection directly from Atlanta to San Francisco. Then any traffic on the network that needs to go between these two cities can go directly. In other words, we built another freeway just for them. But even partial mesh networks, they're more expensive, because in this example, we got 1, 2, 3, 4, 5. It's about, what is it about? There's about 12 freeways there. Okay, so ring, star, and mesh. These, you can have a mesh LAN network just like you have a mesh backbone network, or like a wireless Wi-Fi. You can have Wi-Fi mesh networks. And we do Wi-Fi mesh networks for the same reason, LANs, for the same reason that we do mesh WAN networks, for reliability and to reach a lot of different locations. But we don't usually do this for LANs. So keep these three in mind: ring, star, and mesh, okay, for dedicated services. Layer 2 traffic, not layer 3, but layer 2. Layer 3 is optional. It can be layer 2 or anything about it. We can use IP version 4, IP version 6. We can use a made-up protocol that we made up on our own, as long as it talks on this T-carrier service or SONET service or Ethernet or whatever the layer 2 or PPP, whatever the protocol is. As long as it can talk on that, we can use it. So, advantages and disadvantages to ring: it's robust to loss of any one circuit, but long routes increase the latency. Some traffic may take too long to go from point A to point Z because it's having to go through B, C, and D before it gets there. Star, very simple to manage. It's inexpensive. Circuit failures primarily only affect one site, but it's susceptible to traffic problems if everything has to go through a central site, and failure of the central site will cause the entire network to go down. Carriers, like AT&T, carriers themselves, that's what their networks look like. They have to have a full mesh network because they're carrying traffic of many companies. So Comcast, AT&T, Verizon, Sprint, all of the wireless carriers, their networks are all connected like that because they have to have a very robust, very big mesh of networking. But most organizations that are not in the business of carrying other people's traffic, they're not in the communication business, they'll either go for a partial mesh or a ring or a star. Okay, you got that? Okay, moving on. Here were the two more popular dedicated layer 2. We're talking about layer 2 here. Layer 2 networking services. There was T-carrier service, which we still have, not very popular anymore, but we still have it. And then the newer SONET service. And the basic difference between these two, as you might guess, is this is using the telephone network or copper wiring, and this is using fiber optic wiring. That's where synchronous optical comes from. SONET service. Let's talk about T-carrier service first of all. T-carrier service, most common dedicated circuit switch service still used in North America, and that's because of legacy situations. Because a lot of companies have been there already for 40 or 50 or 60 years. It's been around for a long time. T-carrier service has probably been around, I'd say, since the early to mid 70s. Most common are T1s. There is no such thing as a T2 or a T4. These were both protocols that were developed by the protocol industries like IEEE, but they never got ratified or made available by AT&T or Level 3 or whoever else provides that service. T1 and T3, and actually fractional T1 was available too. So the slowest speed that you could order was called fractional T1, 64 kilobits per second. That's as fast, and the reason it was 64 kilobits per second is that's as fast as they could figure out how to carry digital traffic on the telephone wire that comes to your home or your business from the carrier central office, which is about 8 or 9 miles. Not very far away. T-carrier wires cannot be stretched very far. 10, 12 miles max. So that means that the carrier, AT&T in most cases in the United States, the prevailing carrier has to have a point of presence physically pretty close to your company within a few miles, or they can't provide service to you unless they run something like fiber optic cabling. That's where SONET service comes in. Still pretty popular. If you are a bank or a financial institution or a hospital, or you're carrying data that's critical and not allowed on the internet, you have to subscribe to some sort of layer 2 services. All ATM machines that give you more than $200 have to be on a dedicated circuit service. Most of them are using fractional T1. The wire that comes to them looks like a phone wire, but it's using digital services, kind of like DSL. T1, you can buy a T1 today. They cost about $800 a month for 1.544 megabits per second. That's pretty slow. But it's dedicated. It's your, here we're going to give you a car, doesn't drive very fast. But we're going to give you your own road. And here's a better analogy. We're going to give you your own road. The speed limit is 30 miles an hour. You can drive whatever you want on it. We don't care, but the speed limit is 30 miles an hour. Can't go any faster because the road's too bumpy or whatever it is. That's your T1, $800 a month. Now, most of you guys have much faster than T1 service at home, right? What are y'all's internet speeds at home? Or where you happen to be sitting right now? If you were to go run like speed test right now or something like that, what are you guys getting, like 50 megabit, 100 megabit per second, 60 megabits? Anybody there? 15 to 30, 100 meg down? Yeah, and you're probably paying, what, fares like $60 a month, something like that, $80 a month? $15 a month? Oh yeah, maybe because you got a good deal right now from AT&T or Xfinity. But yeah, you're not going to pay. You can get gigabit Ethernet, not gigabit Ethernet, excuse me, gigabit internet from Xfinity for $250 a month to your business with no caps. But that's the internet. That's layer 3, not secure. So T1, although it's much, much slower, still pretty popular. T3 is the fastest you can get. That'll cost you about $1,200 to $1,500 a month from point to point. There's also 3 components, cost components, because you're paying for, and when you get a bill for T-Carrier service, it's got 3 pieces on it. The first piece, or the first 2 pieces, are going to be what's called the local loop, also called the last mile. Can you guys see that, where I just typed that in the chat? Local loop or last mile. Do you guys see the chat screen on your screen also? Do I need to move it over there, or can you see it wherever? So it's called local loop. Sometimes a local loop costs more money to go 2 miles from your building to the central office than it does to go to 250 miles from Houston to Dallas. I remember I used to have a T1 connection from Houston to Dallas because we transmitted medical claims for our medical billing business. Cost us $800 a month. $500 a month of that was the local loop in Dallas and the local loop in Houston, and $300 of it was the connection between Houston and Dallas. And that's because, or why? Now I'm just going to tell you, that's because we're having to pay for local taxes and rights of way, and infrastructure is in the way inside the cities, but outside the city there is no infrastructure in the way. Know what those terms are. Local loop. We also call it the last mile, even though it's not specifically a mile. It's kind of like in a race, your last leg. Sometimes we refer to you. You got 1 more mile to go. It's the last mile. It's not really a mile, but call that the local loop. The reason we call it a loop, by the way, is because it's DC powered. Now, T1, by the way, that number, that 1.544 megabits, and we just rounded off to 1.5. That is actually 24. Quantity 24 fractional T1s or 2464K circuits. What's 24 by 64? Somebody do that math real quick on your calculator. 24 times 64, that equals 1.536. It ends up being 1.544 megabits. And that's because we used to use the original telephone wiring that went to buildings from AT&T or Southwestern Bell back then, from their central offices to a building, not to a home, but to a building. They would run large packs of cabling that were either 25 pairs or 50 pairs of wires. The cabling coming to your home is probably 2 pairs of wires, or maybe 4 pairs of wires, and you're using one of those pairs for telephone services. So somebody smart back in the 70s said, hey, let's take 24 of those 25 pairs. We'll use one of those pairs as a control pair, and we'll use the other 24, and we'll send digital data rather than analog data across those and combine those together. So it's like building a freeway with 24 lanes on it. We take all your traffic, or we take all your people, and we put all your people in different cars, and they all travel on this 24-lane freeway to go from point A to point B. Notice how I didn't say point Z, and that's because this is layer 2, point A to point B, 25 pair cable. So that's where T1 was born. In Europe, they had 30 pair cabling. So they used all 30 pairs, and that's where e-carrier service comes from. So what does 30 times 24 equal? Somebody do the math there. What's 30 times 24? $720. Oh, I'm sorry. I'm doing that wrong. I was going to say that's not right. 30 times 64K. Excuse me. Sorry. 720 is not right. 30 times 64. What's 30 times 64? Yeah, almost 2 megabits per second. So European services were actually faster. T3 is 28 T1. So if you take 1.544 times 28, you get T3. We couldn't go really faster than T3 because we ran out of wires. Way too many wires. So by the early to mid 80s, fiber optic cabling was invented by Dow Corning. And so we invented a newer protocol to use. So rather than using T-carrier service or PPP, point-to-point protocol, we're using SONET service, synchronous optional. It's an ANSI standard for optical fiber transmission. So the difference between T-carrier service, the first difference is this is copper, this is fiber. Second difference is the fastest available speed, 45 megabits per second right there on copper, which could only be about 10 or 12 miles long max at the local loop. And then they had to do something with it, like either regenerate it on fiber or turn it into wireless or something. OC1, the slowest speed of optical carrier service, is 52 megabits per second. We rounded up. 52 megabits per second. That's getting more in the ballpark. OC service, you can get an OC fiber line from Houston to Dallas for about $1,000 a month. Also, fiber optic wiring, much more secure, physically secure. Also, it can be stretched much further. I don't have to have a central office for a carrier very close to me. That carrier can literally be 30 or 40 or 50 miles away from me. As long as I can get that wire to me, I can get optical carrier service. Now, optical carrier service is not available everywhere. It's only available in major cities. OCs, they've got optical carrier service all the way up to OC 768. OC 768, 40 gigabits per second. That's pretty fast, isn't it? How much do you think OC 768 costs? Let's just Google for that. Let's see if that comes up. Pricing. And this is just internet connection. This isn't point to point. This is just a connection between one single point and the internet. Oh, they're not even publishing their costs because they know it's way too expensive. we're talking about $20,000, $30,000 a month. Much more expensive stuff. Not viable for most companies. Okay. Again, the only companies that usually use speeds, anything higher than OC48 are going to be internet providers or common carriers themselves to carry traffic. Now, let's say you don't have $1,000 a month. You can also opt to do something a little bit different. You can still maintain layer 2, which is what we want. We want layer 2 traffic because it's more secure. But we don't mind sharing our connection. So a packet switch service is available in a lot of places, not everywhere, but in most places, where they basically give you that dedicated freeway, but it's dedicated for you and 10 other companies or 20 other companies. In other words, you have a toll road that's been built and you have a toll card or a toll sticker on your vehicle, and you're allowed to drive your vehicles, whatever they are. We don't care what they are. As long as you got that toll tag on your vehicle, you can get on our toll road. Otherwise, you cannot. So it's still layer 2. It's still secure. Layer 2 frames from different companies don't interleave. I can't pick up somebody else's layer 2 frames. So it's like everybody on a toll road, but you're all in tanks with no windows, can't see each other, can't access each other, can't hurt each other. But what are the disadvantages to that? Has anybody gotten on a toll road? Maybe not recently, but has anybody ever spent the money to get a toll tag, and then you get on the West Park Tollway or the Beltway or whatever, and you run into traffic at 5 in the afternoon, and you're crawling along at 10 miles per hour that you paid for the privilege of doing? That's what a packet switch network is. You have a maximum speed. So supposedly a toll road, and the reason why we have toll roads, why do we have toll roads in Houston? Anybody have any idea? Why did they build toll roads? So we have alternatives, right? So if we want to pay money, if we want to pay a premium to get from one side of the city to the other, that's not a central location like downtown, we can pay for that privilege. But short of building your own freeway, most of us can't afford that. So we pay the few dollar tolls that we need to pay. That's what a packet switch network is. I know that term says packet there, but we're still at layer 2. It's using what's called layer 2 pad packets. This is the only time, by the way, that we don't call the data that goes onto a layer 2 network a frame. It was originally referred to as a packet. Now, these aren't that popular anymore. You can get T-carrier packet service, SONET packet service, Ethernet packet service, even where you're creating Ethernet frames, but they're shared on a local network, on a wide area network. You get what's called a committed information rate and a maximum allowable rate. So if we use our analogy of the toll road, what's the speed limit on the Beltway? Or let me ask you this: not what's the speed limit? How fast have any of you driven on the Beltway at 3 in the morning or 2 in the morning because you had to get home before your girlfriend realized you weren't there yet? 90? Is that all? I've been on the tollway in the middle of the night and people have passed me going 120 miles an hour or more. And they're probably drunk too. It's terrible, but that's what they're doing. So think of the tollway as having a maximum allowable rate, and it's pretty much the maximum is however fast your car will go. But the committed information rate on the belt, what is the committed information rate on the Houston freeways, on the Houston Beltway? Really nothing, is it? But so that's not a really great analogy, but it's variable. That's my point, is they commit and they say, well, we're going to give you a T1 circuit, which is capable of going 1.54 megabits per second, but it might go down to as slow as 384K because your traffic potentially is being shared, or your freeway, your tollway is being shared by other companies that, depending on what they're doing and what time of day it is, it might get a little congested, a little crowded. So make sure you understand these two terms: committed information rate, the CIR, and the maximum allowable rate, the MAR. the maximum allowable rate is typically the maximum speed of that circuit. And it's the same circuit as a dedicated circuit. If you order an OC1, 52 megabits per second, you're going to pay a certain amount. But if you don't have that much money, you want to pay less, they'll give you a package switched OC1, which means it's the same fiber that comes to your building, but you pay less money per month and you're only guaranteed a minimum throughput. We'll give you 52 megabits per second max, but we'll guarantee 5 megabits per second or 10 megabits per second. You're not always going to get that speed. Just like on y'all's connections to your home, you're not, if you're paying for that 100 megabit speed, you don't always get 100 megabits down. It depends on what everybody else in your apartment complex or your neighborhood or your city's doing as to what that speed's actually going to be. The topology looks essentially the same. It's a star topology. Packet switch services are star topologies as far as you're concerned, but the common carrier, their topology interiorly is probably a mesh topology. But the organization, to the company that has these different remote sites, it looks like a star topology. Frame relay, don't see that too often anymore. Again, there's still old ATMs and old banks and legacy sites out there that might still have frame relay, rural sites that might have frame relay. Ethernet, much more popular. Comcast is really heavily pushing what they call Metro Ethernet. Comcast is totally Metro Ethernet. That's just what they call it. And their selling spiel is that we're giving you layer 2 from end to end. The frame that comes off of your LAN in Houston is the same frame that goes onto the LAN in Dallas. We don't mess with it, where we recreate it basically. There's advantages to that, security advantages, speed advantages, because anytime you have to go up higher in your internet model, layer 2, here's layer 1, layer 2's up here, our traffic is, there's not a lot of overhead yet. The moment we go into the IP layer in the middle here, we've had to add some overhead, slows things down. When we had to go to transport and application layer, we slowed things way down. The less we can reduce our overhead. So some companies opt for this Comcast Metro Ethernet, even though it costs more per month than just straight internet connections and using IP, because it's more secure and it's faster and it's a committed speed. You can go Google for that. I always recommend that you guys do this, by the way. Comcast Metro Ethernet. Go read up on what that is. Don't have to do this right now, but go Google for that later on. Comcast Metro Ethernet. This is just one company and one offering that they have, but this will give you a better idea of what I'm talking about, and it'll be more real to you because it is a real thing. I'm not just making this stuff up. Some things I make up, but not this. Don't worry about what a frame relay looks like. It basically looks like Ethernet. You do need to know what this term is, by the way, PSTN. I mentioned the publicly switched telephone network earlier, PSTN. Stands for Public Switched Telephone Network. That's like your phone numbers. Everybody in here has a cell phone, right? And you got cell phone numbers. Your cell phone number is an address on the North American PSTN, the Publicly Switched Telephone Network. So T-carrier service, packet service, frame relay, those operate on the PSTN. SONET service does not operate on PSTN. Now, while we're talking about PSTN, you associate that with phone numbers. I'm just going to ask you this right now. What's the opposite of a PSTN, or what's a private telephone network called? Because we're going to talk about this in later classes because it goes towards management. What's a private telephone network? If PSTN is for public phone numbers, and you understand why they're public because I can call you. You have a number. Any idea? Anybody work for a company and you've got an extension? No, it's a good guess. Good guess, but no. There's a thing called ISDN, by the way, not ISDN. It's called PBX. And I'm just going to mention it now because you need to start looking this stuff up for the third chunk of the class. What does that stand for? Anybody know? Private branch exchange. This is your extension numbers. Like, please call me. I work for HP. My telephone number is 800-555-1212, and I'm at extension 703. That's your PBX number, private branch exchange. We can carry PBX traffic across privately switched dedicated networks, but we don't carry PBX traffic across public networks. We'll talk about PBXs later. Just know what that term is and know what PSTN is. If a technician asks, what's your PSTN address, they're asking for your public telephone number. If they ask, what's your PBX address, they're asking for your extension number. Well, I'm at 702 or I'm at 7513 or whatever your number is at your business. MPLS is just another flavor of Ethernet, which is a more efficient protocol than PPP. You don't need to know the difference. And I'm not going to ask any questions. I might ask a question like, what is a newer layer 2 protocol? And they call it a layer 2.5 because it uses layer 2 and layer 3. It looks a little bit like layer 3. So in packet switch networking, we're actually kind of moving away from using the traditional layer 2 packet switch networking and moving just towards all IP. We're getting rid of layer 2. We're going up to all IP and layer 3. Either layer 3 dedicated networks or just straight up layer 3 internet traffic, and we transmit stuff back and forth from sender to receiver with public IP addresses. So IP, all IP networks, we don't care what the underlying layer 2 protocol is. It slows our networks down a little bit, but it gives us a lot more flexibility because we can't really manage layer 2 traffic very easily. The carriers can, but we can't. We can manage layer 3 traffic. Once something has an IP address, we can manage it. We can control where it goes. We can subnet it while you're doing your subnetting assignment. How many people have heard of VPN in the class? You can turn on your mic and say so, or you can type it. How many people have used VPN before?
I have.
And what have you used VPN to do?
I use it to give tech support for the UH staff sometimes.
Okay, so you get or you give tech support?
Give.
You give tech support to the U of H staff. So, okay.
So I really just use it so I can view what they're doing, but I don't
Okay.
really need it.
But you don't really need that to view what they're doing though, right? You could just use Chrome Remote or Team Viewer, right? Why do you use VPN?
I just like I can guide them. I can do it at the same time. They usually need the VPN, but I just guide them with it. Like as I'm doing it, I'm guiding people, but I don't need it. They need it to access certain.
Oh, you're
databases
helping them
and
set
stuff.
up VPN. Okay, I got
Yeah.
you. Okay, so, and maybe some of you others have used VPN to access content that was not available in the country you happen to be in. Like some of you might know that there are certain content on Netflix which is available in Europe that's not available in the United States because maybe it's still in the movie theaters, or maybe the production company hasn't signed a contract with a provider here to show it on the internet or on Netflix or whatever, so it's not available here. So you go and you download and you subscribe to a VPN service like Aloha VPN. There's literally hundreds of these. I used to use Aloha VPN to watch BBC TV on the internet because I like to watch Doctor Who. One of my favorite shows. Any Doctor Who fans out there? No, yes, maybe? I don't know. Doctor Who, pretty cool stuff. It's a really neat British sci-fi show about a guy that travels around in space and time and fixes people's problems. He's kind of like God. Not past season 10. Oh, you got to get to season 13. Doctor Who's a woman now. David Tennant is the best Doctor Who. Actually, you can stop at David Tennant. He's the best one. Matt Smith is kind of weird. Anyway, what was I talking about? Oh, why I use a virtual private network. I use a virtual private network because we need to make it look like we're coming from somewhere else. Whoever was talking earlier, you're using a VPN because, or you're showing your U of H staff how to use a VPN so that they can access local resources from home or from a remote site as if they're still at the local network.
Yeah, that's right. So they can do research most of the time.
Right. So they don't have to use Chrome Remote or TeamViewer or go to My PC or any of these other remote viewing programs to remote view a machine that's sitting on a desk in their office. They can just access the shared hard drive, the F drive or the S drive or whatever it is, from their actual laptop, regardless of wherever they are. They could be in an airport, they can be on a cruise ship, they can be at home, they can be, wherever at Starbucks, and it still looks to them like they're on their local network. So VPN, much, much more popular now, especially with the situation that we're in. Everybody now, unfortunately, is having to work from home or go to school from home. So if you have, let me get back to this. So a VPN may use dedicated hardware. So in the case of most companies that are employing the use of VPN to create a virtual WAN connection, they're using hardware. They're using routers that have VPN software built into it. For you guys that are out on the road using your laptops or at home using your laptops, you're probably using what's called an Access VPN. We also call it Road Warrior VPN. Can you see, do you guys see the chat window as I move it around, or are you seeing your own chat window? Do you guys see this? Okay, that's what I thought. I just wanted to make sure. So you're probably saying, you possibly used Road Warrior VPN. We call that Road Warrior because these are the salespeople or the management people that are out, that live in airports. Some of you guys, eventually, when we get back to normal, that's what you're going to do for the first 5 years of your life. You're going to live in airports, traveling from Houston to Dubai to nowhere, Oklahoma, because you're working for an oil company, and you're going to live on your laptop, and you're going to be running VPN software so that it looks like you're on your local company's internet or intranet, I should say, for purposes of security. So VPNs can be implemented at layer 2 or layer 3 or even layer 5. A virtual circuit gets created. So let's go back to the PowerPoint here. Here's some new terms for you. So maybe you've heard of VPN. Here's an example of a local office and a remote office that want to connect to each other, but they can't afford a dedicated service. It's too expensive. Or they need something very quickly. So we tell the two offices in the remote locations, get an internet connection with the prevailing carrier that gives you the best deal, whether that's Cox Cable or Time Warner or Comcast or Sprint or whoever it is, whatever the prevailing carrier is that will give you internet service and an IP address, that's all you need. So you get an IP address. Then you install another piece of hardware between you and your local network called a VPN router, or sometimes this is a single device that connects you to the internet as well as connecting to the internal network. That would be called a gateway. That's VPN capability. And a lot of people's home gateways have VPN capability. They're running what's called OpenVPN. There's another gateway talking the same protocol at the other end somewhere. These two guys establish a connection publicly with public IP addresses. They take traffic on an internal network. Let's say you've got an internal network range of 192.168.1. something, and you want to put that traffic onto this network, which is 192.168.2. something. And you want those two networks to basically be bridged together so that you can share local network traffic. This gate, all that traffic goes to this gateway. He takes off the internal numbers, encapsulates, called encapsulation, that's the term, encapsulation, takes that layer 2 traffic, or even layer 3, it could be layer 2 or 3, encapsulates that into another layer 3 packet which has a public IP address, sends that across the internet. It's encrypted, hopefully. You can do VPN without encryption, but we don't recommend it. Then it gets decapsulated, the opposite of encapsulation. On the other side, turned back into a frame or turned back into the local layer 3 traffic and dumped out onto the local network here. This virtual connection between point A to point Z here, or in the case of a company, it looks like point A to point B, is what's called a VPN tunnel. So the verb is tunneling. We are tunneling our traffic by using encapsulation. Encapsulation is taking local traffic at layer 2, moving it into layer 3, or taking local layer 2 traffic, turning it into public layer 3 traffic, and then encrypting it, sending it across the internet, whatever the internet connection is, to another public IP address where it gets untunneled and decapsulated and thrown back out onto the local network. Anybody ever been to a bank before, like a physical bank, through the drive-through? Maybe that's a foreign concept to a lot of you, but back in the old days, us old people would drive to a bank. We'd sit in our cars, we'd go to a drive-through. Maybe there was a window, but a lot of times there is several little stations that you drive up to. And this little station has a door on it. You open the door and you take out this tube that's in there. It's like a little 1 foot long tube, and you opened up that plastic tube and you put your checks or cash or deposits or whatever in that tube. You put it inside the device, you pushed a button, and that tube shot through a tunnel like this tunnel here up to the bank. And then they opened the tube, they got the stuff out, and they did whatever they needed to do, and then they put their data, they put the deposit slip with your sensitive data back in that tube, shot it back down the tube to you, and you picked it up and drove away. That's an analogy of what's going on in VPN tunneling. We're encapsulating. You're taking your data, taking your important stuff, sticking it in a tube, basically, or in a packet, running it through a tunnel. It's getting unpacked on the other side. Okay, VPN. Now, some of you are familiar with, as I mentioned before, access VPN. Let me talk about intranet and extranet for a minute. These two terms, intranet and extranet. An intranet is where a company uses internet technologies, not dedicated services. They use the internet, which is available everywhere on the earth pretty much. And we provide a virtual circuit, not a physical circuit, but a virtual circuit between organizations over the internet. So we call that an internet VPN. In cases where the organizational locations are not related to each other, or they are loosely related to each other, such as one bank to another bank, or a doctor's office to an insurance company, where we need to send sensitive data, but we don't want a dedicated circuit service to them because it's too expensive, but we need to have something a little more secure. We use an extranet VPN. So the only difference between these two things, they're using the same technology. It's just a matter of, are these two organizations, these point-to-point organizations, are they related or not? Is it two locations of the same business, or is it two different locations of two different businesses? Intranet versus extranet, okay? You'll hear those terms a lot more if you ever sit through any boring marketing presentations or cost analyzing presentations where they talk about, we're gonna leverage our internet technologies and create a company-wide intranet and then invite our vendors onto our extranet for purposes of security, et cetera, and so forth, and blah, blah, blah. So make sure you know what those two terms are. Access VPN, this is where you are using a VPN. Typically, you install it as software on your laptop, and the most common one, and the one I'd like you guys to try using, I'm gonna do this. I'm gonna set up an assignment that is in lieu of some of the lab assignments that we would normally be doing in the EI lab, since we're not gonna be going back to the EI lab, using OpenVPN. OpenVPN is software that you can download for free. That's why it's called OpenVPN, on Windows, on a Mac, on an Android, on an iPhone, and install it. And then with a username and password and an IP address, which I'll provide to you guys at a later time, you can log into a remote network and get onto that remote network. So I'll set up, I already have set up, but I need to give you some credentials. In the EI lab, I have an open VPN server running in there. I'll give everybody username and I'm going to try to figure out if I can use your credentials that are on the Windows server to authenticate your VPN connection. So what you need to do between now and Monday, when our next class is going to be, like I said, I'm going to try to have one sooner, but I think I'll make it asynchronous for I might do asynchronous for chapter 10. But download OpenVPN, read the documentation online on what OpenVPN is and why you use OpenVPN, and start to get familiar with it so that when I do email you or publish on the Blackboard site, here are your credentials, here's how to log into this OpenVPN, and here's the experiment that I want you to do. I want you to access these local servers or these local share locations and try to upload and download files directly out of your computer by using copy and paste, for example. Not using FTP, but using cut and paste. Very powerful stuff. There's another example of what's going on with a Road Warrior VPN. I've got a laptop. I'm sitting in a house somewhere. I'm running software on my computer. Everything is being encapsulated in the software. Everything is being encrypted, then encapsulated. I'm using my public internet connection, and then the server that I have set up at the other end, the VPN server, is accepting that traffic. Or you can do laptop to laptop even with OpenVPN as well. Okay, advantages to VPN. There are actually several more advantages to this, but the primary advantage is it's inexpensive. It's also instantaneous, meaning if I need to set up a private network between two sites, let's say at layer 2, because I need to share some camera information or some printer information. It only works at layer 2. It's going to take me weeks to get a dedicated connection in, but wait a minute, I can just pull out my cell phone here and turn on my Wi-Fi hotspot and connect my laptop to my cell phone, run VPN software on my laptop, and connect into my company's intranet at my home office, and I'm getting layer 2 traffic and the protection of that. It's almost instantaneous. Flexible, I can be wherever I want. I can use anybody's internet connection that's reliable. I can use multiple internet connections. If I got 4G LTE today and then I go and I get a Comcast account and get it installed tomorrow, I can start using that. Very flexible. Disadvantages are that the internet traffic, as you guys know, is very unpredictable. It's not dedicated. So it's like the difference between using a tollway or using your own freeway or a rented freeway and using the streets of Houston to go from point A to point B. You need to go from here to U of H and it's 3 in the morning. That's not a problem for most of you. You can probably go, pretending there's no speed limits or there's no cops on the road. You can go as fast as you want. There's no traffic and you'll get there. But if it's 5 in the afternoon or 9 in the morning, it might take you an hour or more to get to U of H, depending on where you are in the city. That's similar as to what's going on with VPN. Also, there's multiple incompatible implementations of VPN. Cisco does their own thing. Amazon Web Services, they have their own flavor of VPN. Oracle has a VPN. Juniper has a VPN. OpenVPN is a different kind of VPN. And there's also lots of different parameters within the VPN software itself that even if you're using OpenVPN on both sides, if you don't have all of the parameters set the same on both sides, like the type of encryption you're going to use, the amount of encryption that you're going to use, whether you're going to use encryption at all or not, if it's not set up right, you're not going to pass any traffic. There's about 20 different encryption protocols that you can set up. So sometimes VPN is a challenge to get working, especially if it's if it's an extranet, or we're using different pieces of hardware, like we're trying to get a laptop, a PC laptop running OpenVPN to talk to a Juniper switch or Sophos or Cisco or any of the other popular pieces of hardware that are out there. How are we doing on time? Oh, we're almost there. Okay, and WAN design practices. When dedicated guaranteed service speed is required, we look at dedicated carrier services. The advantages to those are they're dedicated. The cost is relatively high, moderate to high. The time to get it installed is high. They're long-term contracts, 3 to 5 years. That's another nice thing about VPN in the flexibility in that it's, you know, I'm already paying for an internet connection. I don't have to pay for anything extra. Just have to add some software, and it's temporary. Or I can borrow somebody's cell phone, or I can borrow Starbucks and do a VPN from there. But the reliability is very high. Packet switch service, it's basically the same thing as T-carrier or SONET service. You're still using a dedicated service, but you're sharing it with other companies. It is secure and it's reliable, but it suffers from potential speed degradation because other companies are using it at the same time. Less expensive. The least expensive and the most flexible is VPN, but it actually is the least secure. Now, I'll argue with the book, and the book says that VPN is very secure. I argue that it's very insecure because if I happen to get a hold of your VPN credentials, your username, your password, and I know what IP address to connect to at your company, I can hijack or take over your VPN connection. So although the security is very good with the function of the VPN, like the key to get in the door, it's a very well-made key and it's a very well-made lock on the door. But if you lose the key or you give it to somebody else or somebody figures out how to copy that key, that high quality of key manufacturer doesn't do you any good. So VPN, not very secure because of that. It's up here. VPN's at the application layer. It is an application. Data link layer, layer 2, no way you can jack into one of those networks unless you can manage to hijack the Wi-Fi, and that's much more complicated to do. It's also much more controllable. Okay, how do we improve WAN performance? We can do the same thing to WANs that we do to LANs. We don't typically have servers and clients involved with our WAN performance issues. It's usually the devices, maybe they're legacy devices, or they're handling too much traffic. So we can either add more devices, as in the case of going from a star topology to a ring topology or a mesh topology. That's literally more devices and more circuits. Or we can upgrade the devices. A lot of times you can take routers that you have that are doing VPN and add more memory to them, and that will get faster. Or you can decrease or increase the demand. Put static files physically closer to the users. Put them on, have a local network, and we do this with a lot of our remote sites. Some companies opt to have one domain controller throughout the whole company, and it's located in a main office like in Dallas. And everybody turns on their PCs in the morning, and they have to authenticate on that domain controller in Dallas, but that can get really slow in the morning. So what we do is we have backup domain controllers or alternate domain controllers within each of the local cities, Houston, San Antonio, whatever, and they copy overnight, they copy and they maintain their own copies of the user profiles and the data profiles, who's allowed access to what data and what printers. That's not very much data to duplicate every time. Also, that data doesn't change very often. Most people don't change their password every day. So we decrease the demand by moving static data or data that doesn't change very often closer to the user, not on the VPN, on the local network. We don't share some traffic that doesn't need to go on the VPN. We don't put it on the VPN. PBX traffic, for example, telephone traffic, it may not be as critical to encrypt or hide telephone traffic PBX traffic, as I was mentioning earlier. So don't run that through your VPN. Also, telephone traffic and video traffic takes up a lot more data and a lot more bandwidth than just typing. Let's take that outside of the VPN. Let's not put that on the VPN. Let's do that outside of it, so we're not bothering to encapsulate and encrypt a bunch of video and voice data, which is not nearly as not needing nearly as much security. Okay, and the implications for management, this is basically the future, or the current or the future, what's going on. There's T-carrier service is becoming quickly extinct in place of, it's being replaced by SONET service, which you can order now from most carriers if it's available, or you can order Ethernet, an MPLS service. Also, a lot of small to medium-sized companies are not using those dedicated services at all. They're just opting for VPN. U of H uses both. We use the VPN service to provide our employees and our students an outside connection to our inside network, but we also have dedicated services to connect all of our campuses together. The Sugar Land campus, Victoria campus, Clear Lake campus, they're all connected together in a wide area network. We don't own that cabling. We pay a bunch of money to different common carriers like Sesquinet and AT&T. And also standardization and commoditization of those protocols and the hardware is occurring. More providers are trying to make their hardware work together and their protocols work together, because not every provider can be everything to everybody. Not every carrier is located in every city. But if they can sign a contract, if AT&T can sign a contract with Comcast and say, hey, we don't provide services in that little city, but you do, and we've got some customers that have sites in our area and your area that want a layer 2 dedicated network. Why don't we make a connection and we'll share some services there? Okay, so that is it for chapter 9. Any questions other than when is exam 1 going to be finished graded? I promise I'll, as soon as I hang up from this and save the video, in which I will publish this video, there'll be 2 versions of this. There's a 2:30 to 4 version, and then there's a 4 to 5:30 version. They're pretty much going to be the same thing. If you are a glutton for punishment or just really love me that much, you can watch both of them. I'll send you the links for both of them on YouTube. Exam 2 should for sure be up tonight. No, it should not for sure be up tonight. That depends on how much more time I had to spend on exam 1 dealing with that, and also dealing with emails that I've been getting over the last couple of days. So I'm going to try to make it available, but more than likely I'm going to make that available tomorrow in the morning and make that available through Sunday at midnight. I led the other class to believe it would be next Wednesday, but I think everybody in the 2:30 to 4 class also thought it was Monday. How many of you in here don't really know what day it is? Or it feels like you don't know what day it is? Will the videos for the previous classes be in Blackboard? No, they will not. They will be on YouTube. I've already published. And if you look on Blackboard, the link for the subnetting YouTube video is there. You can go watch that right now. I've created a YouTube channel called the MIS 4477 channel. It's not a public, well, it is a public channel, but it's not like publicly advertised. Today is trash day. So it's either Wednesday or Saturday. Oh, well, for you, that might be. My trash day is Monday and Thursday, though. So yeah, you knew it was Wednesday or Saturday because the truck woke you up this morning. Is that what you're trying to say, Danny? Okay. All right. So if there aren't any other questions and you don't feel like listening to me or seeing me anymore, I'm going to stop the video. I'll publish all of these on YouTube, but right now my focus is going to be getting all of the exam 1s graded, and then read all the sob stories, or a few sob stories, in email and decide what to do with those. And just keep in mind, nothing this semester is written in stone. Okay. to get a good grade in this class, and I'm not saying everybody's going to get, this is not an easy A class like some people say. You still have to show me some effort. You still have to do the work. There's, 2 or 3 of you that are not doing any work. So those are the 2 or 3 that are going to get a C, but a lot of you are going to get A's and high B's because you're showing that you're doing the work and you're also bearing with me. So I'll see you guys on Monday officially, and you might see me asynchronously because I'll also post a chapter 8 video as well. Enjoy your week as well. Stay safe. Don't cough on anybody. Bye-bye. Go Cougs.